Alright, so this is going to be my mechanical explanation for those of you who want to try and build something similar to this. First off, we're going to start going through the run mechanism, what makes it actually work, and then we'll talk about the programming when we get to that. So first in the run is you press down the bar, you turn this halfway, you let go of the bar, and you turn it the rest of the way. Now each step in that is very important. Now the first step, pressing up on the bar, really only does one thing. Throughout the whole machine, you see these yellow bars that are going up down here? They're connected by rubber bands to that bar so that when the bar goes up, these go up. Now it has to be rubber bands because, or something like that, I know you could do something different, but sometimes they have to stay down while all the others still go up. In fact, all of them are going to be down sometimes, or just one will be up. Now this entire machine is based on if statements according to these yellow sticks down here. If it goes up, it'll push this gray stick up, which then is pushed over by the run mechanism, which moves the bits. In this case, the if statement is determined by this gray peg down here. When the machine has A at 0, the yellow peg can't go up, so it doesn't push the gray thing, which won't push these orange pegs on top. But if the machine is at 1 for A, then this orange thing can go up, which will push A and C to 0. So this if statement is if A equals 1, then A and C equals 0. Alright, so I've changed this program around a bit. It's got the same thing on this first one, except I took off the C part. So if A equals 1, then it pushes A to 0. But on this other side, I also added another part, so that if A equals 0, it pushes A to 1. So every time I run this program, it's going to switch back and forth. Notice that on this side the gray is blocking it, and on this side it's allowing it to go up. Now this brings about a very important thing, is when this yellow stick goes up, you can't let this gray part go over while the yellow is up. That was the biggest problem in building this thing, is that something has to hold the gray up while you let the yellow go down, and then it pushes. If you don't do that, watch what happens to this gray stick watch what happens to this yellow stick as the gray pushes over. The yellow stick will push the gray thing, messing up the entire machine, so that this can't toggle back and forth anymore. And that's exactly why I had to do a 4-motion run routine, which is pressing down the bar, moving this halfway, then letting go and pushing it the rest. And you can see that clearly when we look at this first part again. Zooming in a bit. Well, first off, here's that bar we were just looking at back here. Should be able to move back and forth, yeah. And right up front here is what happens when I turn this run thing the whole way over on the right side. You can see it has a little peg here that would catch onto the gray and push it to the center. So when I run it, I push down that, turn the run thing halfway, just so the peg is touching the gray so that it doesn't allow the gray to drop. But the yellow thing in the back does drop. It was up. So when I run it, it catches the gray and allows the yellow to drop so that the gray can push over without catching the yellow on that gray peg back there. And here we're just taking a quick look at the relationship between the gray and the yellow sticks. If I push up the yellow stick from the back, you can see that it raises this blue stick by a hinge here, which in turn pushes up the gray, so that when the gray is held up, the yellow can still drop back down. That's really important, because if they were actually connected, then the yellow wouldn't be able to drop back down while the gray stayed up. This was the hardest part about building it, and it takes up the most room. So if anyone could find a way to get rid of that, it would definitely make this thing a lot smaller. One major weakness of the Digicomp is that each side of the major logic gates can only return one number. For example, this side can only return a 1, this side a 0. Oh, sorry. This side a 1, this side a 0. This side a 1, this side a 0. This side a 1, and that side a 0. So, in order to compensate for that, the Digicomp maker made a mechanical OR gate. Instead of using 2 of these, you're going to use 1 of these. So I actually replicated that in Connects, and if you can see there in the center, that blue stick right there, If I raise the yellow stick on the left side, it will raise the gray stick on the right side. And if I raise the yellow stick on the right side, it'll also raise the gray stick on the right side. Oops, sorry, I have an if statement in here. There. So either one I raise, it's going to raise the gray stick.